Dear students, today we are going to discuss the previous year SSC JEE questions on the topic transformer. This would be part 1 session. Okay, have a look on the screen. See problem here. A transformer has maximum efficiency at full load when iron losses are 800 watt, copper losses at full load will be. देखिए दिया हुआ है मैक्सिमम एफिशिएंसी फुल लोड पर अकर हुआ है और कॉपर आयरन लॉस जो है वो 800 वाट है। आप जानते हैं जिस लोड पर मैक्सिमम एफिशिएंसी अकर होता है उस लोड पर होने वाला कॉपर लॉस आयरन लॉस के बराबर होता है। सवाल में ही दिया है मैक्सिमम एफिशिएंसी अकर्स एट फुल लोड, मतलब फुल लोड पर मैक्सिमम एफिशिएंसी अकर हुआ है। कहने का मतलब फुल लोड पर होने वाला कॉपर लॉस आयरन लॉस के बराबर होगा। सो दैट PCU indirectly given, PCU is taken here to represent the full load copper loss. So full load copper loss PCU is given as 800 watt and then सवाल पूछ रहा है copper loss at half of full load will be. So आप जानते हैं copper loss at x of full load is equal to x square times full load copper loss, and so see copper loss at half of full load would be equal to half square into 800, meaning is what 1 by 2 square into 800 would give you 200 watt. यहाँ पर x का वैल्यू हाफ लिया गया है just to account the fraction of loading. Your next problem here, 100 volt by 10 volt 50 volt ampere transformer is converted to 100 volt by 110 volt auto transformer. The rating of auto transformer will be. So see here K value is given for auto transformer. K value for auto transformer is given as K is equal to 100 divided by 110 is equal to 10 by 11. अब K का वैल्यू मालूम है, आप डिटरमिन कर सकते हैं KVA ATR that is equal to 1 by 1 minus K times KVA 2 winding transformer. So just to put the values 1 by 1 minus 10 by 11 multiplied by 50, it will give you 550 volt ampere. Next सवाल है area of hysteresis loop represents. Say area of hysteresis loop represents hysteresis loss per cycle of supply. See next. The purpose of conservator in a transformer is. See the purpose of conservator in a transformer is to maintain constant pressure inside the main tank and to take up the contraction and expansion of oil due to rise in temperature. So the correct option is this one only. In case of transformer, the no load current in terms of rated current is, it is 3 to 5% of the rated current. Next problem you see, in copper loss of transformer at 7 by 8 of full load is 4900 watt, then its full load copper loss would be. देखिए दिया हुआ है 7 by 8 ऑफ फुल लोड पर कॉपर लॉस 4900 वाट है। देन इस ट्रांसफार्मर में होने वाला कॉपर लॉस क्या होगा फुल लोड पर। अब x ऑफ फुल लोड पर कॉपर लॉस मालूम है, देन फुल लोड पर मालूम करना है। आप जानते हैं कॉपर लॉस at full load is equal to copper loss at x of full load divided by x square. यहाँ पर x का वैल्यू 7 by 8 है। So just to put the values, it will be equal to 4900 divided by 7 by 8 whole square. It will give you answer as 6400 watt. Next you see, if a 500 kilovolt ampere 200 hertz transformer is operated at 50 hertz, its KVA rating will be. देखिए KVA rating of transformer is directly proportional to frequency. अब frequency का रिडक्शन हुआ 1 by 4 times, then KVA rating में भी रिडक्शन कितना होगा, सेम 1 by 4 times. So 1 by 4 times रिडक्शन होने के लिए सिंपली नया KVA रेटिंग जो होगा that would be equal to 1 by 4 multiplied by 500, it would be equal to 125 kVA. नेक्स्ट सवाल है the power factor at which transformer operates. See the operating power factor of transformer basically depends on load power factor or the nature of load. Next, the efficiency of 100 kVA transformer is 0.98 at full load as well as half load. For this transformer at full load copper loss will be. देखिए ये पर यूनिट एफिशिएंसी दिया हुआ 0.98 एंड एफिशिएंसी सेम है फुल लोड पर भी एज वेल एज हाफ लोड। आप जानते हैं एफिशिएंसी कर्व is a double valued function. Same efficiency can be obtained at different two loadings. Okay, so per unit system के लिए आप efficiency का expression लिख सकते हैं. Eta is equal to 1 by 1 plus PCU plus PI. Here PCU is the full load copper loss, PI is the iron loss. One is your kVA rating in per unit system and power factor consider किए हैं unity, loading है full load. So simply it would be output power in per unit system can be 1 only. So 1 by 1 plus PCU plus PI. This is your efficiency expression in per unit system at full load. Now it is equal to 1 into 1 by 2 by 1 into 1 by 2 plus 1 by 2 whole square into PCU plus PI. This is what the expression of efficiency in per unit at half load. ये दोनों बराबर ये दिया हुआ है सवाल में ही. अब ये बराबर है, देन से इसी को सोल्व करने से फर्दर आप पाएंगे 1 by 1 plus 1 by 2 PCU plus 2 PI. देखिए ये एक्सप्रेशन एफिशिएंसी एट फुल लोड इक्वल्स टू एफिशिएंसी एट हाफ लोड ये सवाल में दिया हुआ है. ये बराबर होगा ऑब्वियसली तब PCU प्लस PI बराबर होना पड़ेगा हाफ PCU प्लस 2 PI. सो you just solve this math here. PCU plus PI would be equal to half of PCU plus 2 PI. Then we'll get half of PCU is equal to PI, and that is which implies PCU equals to twice of PI. मतलब full load copper loss equals to twice the iron loss, meaning is what? Full load copper loss is more than core loss. Next, high leakage transformers are off. Say transformer's kVA rating is inversely proportional to leakage impedance. So high leakage transformer means having a high leakage impedance. So if leakage impedance is larger, then kVA rating obviously would be smaller. Means high leakage transformers are of small kVA rating or volt ampere rating. Then सवाल है Buchholz relay cannot be used on. देखिए Buchholz relay is a gas actuated relay and that can work or can be used only in case of wide immersed transformer having a rating greater than 500 kVA. Although in options here C it would be a kVA only. It would be kVA only. So say with respect to Buchholz relay, ऐसा 500 kVA ट्रांसफार्मर के लिए Buchholz relay यूज करना इकोनॉमिकल होगा, 1000 kVA रेटिंग ट्रांसफार्मर के लिए इकोनॉमिकल होगा. इस 3 फेज ट्रांसफार्मर में मान रहे हैं ये वाइड इमर्स ट्रांसफार्मर है, लेकिन इसके लिए भी इकोनॉमिकल होगा. एयर कूल्ड का कहने का मतलब ये समझेंगे कि वाइल इमर्स नहीं है ट्रांसफार्मर में, वाइल नहीं यूज किया जा रहा है ट्रांसफार्मर कूलिंग के लिए, ये सिंपली एयर कूल्ड ट्रांसफार्मर है. ऐसा दिस वुड बी द प्रीफरेबल आंसर for the given problem here. Okay, next सवाल है a transformer is working at its full load and its efficiency is also maximum. The iron loss is 1000 watt, then its copper loss at half of full load will be. Efficiency ट्रांसफार्मर का मैक्सिमम अकर हुआ है और ट्रांसफार्मर ऑपरेट भी हो रहा है फुल लोड कंडीशन में. अब आप जानते हैं at maximum efficiency the loading at which maximum efficiency occurs copper loss equals to iron loss. So indirectly दिया हुआ है full load copper loss is equal to iron loss that is equal to 1000 watt. Means full load copper loss PCU is given as 1000 watt. Then calculate करना है copper loss at half of full load. अब copper loss at half of full load would be equal to half square into 1000 means 1 by 4 times 1000. That would be equal to 250 watt. Next सवाल है 2 kVA transformer has iron loss of 150 watt and full load copper loss of 250 watt. The maximum efficiency of transformer will occur when total loss is. Say at maximum efficiency total major loss, that is sum of the iron loss and copper loss, is equal to twice the iron loss. So what is the iron loss there given? It is equal to 150 watt. Meaning is what? Total loss is equal to 2 into 150, that is equal to 300 watt. Next सवाल है potential transformers are used. You see this potential transformer used for two purposes in electrical system. One is for the measurement purpose in case of high AC voltage system, and another one is for the protection purpose in high voltage circuits. So here both options are present. These two options are correct here. Okay, next सवाल है a 20 kVA 2000 by 200 volt two winding transformer when used as an auto transformer with constant voltage supply of 2000 volt it is capable of handling. टू वाइंडिंग ट्रांसफार्मर को रिकरेक्ट किया गया है ऑटो ट्रांसफार्मर कनेक्शन के लिए जिसका सप्लाई वोल्टेज 2000 वोल्ट होना है एंड ये सवाल पूछ रहा है इट इज कैपेबल ऑफ हैंडलिंग. देखिए ऑटो ट्रांसफार्मर जब भी रियलाइज किया जाएगा टू वाइंडिंग ट्रांसफार्मर से दो बात ध्यान रखेंगे. अनलेस अंटिल इट इज मेंशन्ड you should consider that the two windings of the transformer are to be connected in series additive connection, and second one is HV winding of the two winding transformer should be placed or should be taken as common winding. So टू वाइंडिंग ट्रांसफार्मर का जो HV वाइंडिंग होगा वो कॉमन वाइंडिंग होगा एंड जो दोनों वाइंडिंग का कनेक्शन होगा that would be in such a manner so that they are in series additive polarity. So see please the connection here, this would be your 2000 volt winding and this is your 200 volt winding, this is your 200 volt winding. These two windings are connected for series additive connections so that you can get 2200 volt on the load side. Now this is what your HV voltage rate, HV side voltage rating of ATR and this is your LV side voltage rating of ATR. So K value of ATR is given as 2000 divided by 2200 volt. This is your LV, this is your HV. So K value is equal to 10 by 11. Now you know KVA rating of ATR is equal to 1 by 1 minus K, that is 1 by 1 minus 10 by 11 multiplied by KVA rating of two winding transformer. Here you take 20 KVA and it would give you what? It would give you 220 kilovolt ampere. Next, power transformers are designed in such that maximum efficiency occurs at. Say power transformers are designed in such a manner so that maximum efficiency occurs near to full load. Okay, अगर ये डिस्ट्रीब्यूशन ट्रांसफार्मर के लिए सवाल होता then that occurs near to half load. नेक्स्ट सवाल है in a single phase transformer copper loss at full load is 600 watt. At half of the full load the copper loss will be. फुल लोड पे कॉपर लॉस मालूम है, हाफ ऑफ द फुल लोड पे निकालना है. सो सेम सवाल आप सिमिलर सवाल आप पहले भी देख चुके हैं. At half load copper loss would be half square into full load copper loss, that is equal to 1 by 4 times 600 watt, that is equal to 150 watt. Next सवाल है an auto transformer used with sodium vapor lamp should have high. Auto transformer supplying sodium vapor lamp should have high leakage impedance just to limit the current supplied to the sodium vapor lamp and so that current flowing through the sodium vapor lamp can be within its permissible limit. करंट वैल्यू जो है विद इन द परमिसिबल लिमिट होने के लिए और कम होने के लिए इम्पीडेंस जो है ट्रांसफॉर्मर्स इम्पीडेंस जो है वो हाई होना चाहिए. ट्रांसफॉर्मर्स इम्पीडेंस हाई होने का मतलब है लीकेज इम्पीडेंस का हाई होना, जेड लीकेज का हाई होना. लीकेज इम्पीडेंस हाई हो सकता है रेजिस्टेंस ऑफ वाइंडिंग को इंक्रीज करके एंड दूसरा पॉसिबिलिटी है लीकेज रिएक्टेंस को इंक्रीज करके और वाइंडिंग लीकेज रिएक्टेंस को increase करके. Between these two possibilities, see possibility number 2 is preferable. By increasing the winding leakage reactance is the increment in leakage reactance and hence a limitation in the current value is a highly appreciated or a highly permissible here. Why? Because with the increase in winding resistance, what will happen? There would be a huge amount of losses in the transformer itself, but see with the increase in leakage reactance there would be no losses. It would not affect the losses in windings or no, it would not affect the extra losses in winding. Auto transformer is used with sodium vapor lamps should have high leakage reactance rather than having high winding resistance. Okay, next सवाल देखिए in an auto transformer the number of turns in primary is 210 and secondary winding is 140. If the input current is 60 ampere, the currents in output and in common winding are respectively. Have a look on the screen. Let's see the auto transformer connection here. This is your uncommon portion of the winding I'm considering and this is your common portion of winding I'm considering. This is your tapping point and secondary side load is connected. So ये दिया हुआ है प्राइमरी करंट 60 एम्पियर है एंड द जो प्राइमरी करंट है वही ऑब्वियसली अनकॉमन वाइंडिंग के थ्रू फ्लो करने वाला करंट होगा। अनकॉमन वाइंडिंग का जो नंबर ऑफ टर्न्स है वो 210 है एंड कॉमन वाइंडिंग का जो नंबर ऑफ टर्न्स है वो 140 है एंड लोड साइड करंट मालूम करना है I2 इज इक्वल टू व्हाट। पहली बात तो आपको ये समझना होगा यहाँ पर ऑटो ट्रांसफार्मर में जो कनेक्शन होता है दो वाइंडिंग का, कॉमन वाइंडिंग और अनकॉमन वाइंडिंग जो होते हैं, दे आर कनेक्टेड इन सच ए मैनर, a tapping point is provided in such a manner so that common winding and uncommon windings are connected in series additive polarity, meaning is what, अगर dotted terminal ये है uncommon winding का, then undotted terminal then common winding का dotted terminal ये होना चाहिए, means undotted terminal of the uncommon winding should be connected with the dotted terminal of the common winding so that it can satisfy the Lenz's law, or so that the primary EMF can opposes the secondary EMF, or secondary EMF can opposes the primary EMF. Meaning is what? Current flowing through uncommon winding, if it is leaving the dot, then current flowing in the common winding should be such that it should enter the dot. Okay, so this would what be the IC current. Now first to determine I2 value. I2 value can be determined, you know, the current ratio's relationship with the turns ratio, that is I2 by I1 is equal to N1 by N2, and then you can determine I2 is equal to N1 by N2 multiplied by I1. So what is the value of N1 and N2 here? N1 is you take 200 and N2 is your 140. I1 is already given, that is 60, you will get 90 ampere. So I2 value 90 ampere मिल गया आपको। अब आप टैपिंग पॉइंट पर KCL अप्लाई करिए। एट टैपिंग पॉइंट ऐसा अप्लाई KCL, और अप्लाइंग KCL you will get, you can write 60 plus IC is equal to I2, and I2 is equal to 90 ampere. So IC is equal to 90 minus 60, that is equal to 30 ampere. Okay, so you can choose this option as correct one. Next, a three-phase transformer has its primary connected and secondary in a star. Secondary to primary turns ratio per phase is 6. Then for a primary voltage of 200 volt, the secondary voltage would be, देखिए जो प्राइमरी वोल्टेज मेंशन है दिस इज योर लाइन टू लाइन वैल्यू, एंड जो सवाल पूछने वाला ये पूछ रहा है सेकेंडरी वोल्टेज कितना होगा, ये भी आपको लाइन टू लाइन वोल्टेज ही पूछा जा रहा है थ्री फेज सिस्टम में। सो कनेक्शन है डेल्टा स्टार ट्रांसफार्मर। अब आप जानते हैं सिंपली रेट वोल्टेज और लाइन टू लाइन वोल्टेज V1 लाइन डेल्टा कनेक्शन बाय V2 लाइन स्टार कनेक्शन वुड बी इक्वल टू, अब डेल्टा कनेक्शन में लाइन टू लाइन वोल्टेज और फेज वोल्टेज सेम होता है, मैंने इस वक्त इक्वल टू V1 फेज डेल्टा whereby स्टार कनेक्शन में लाइन टू लाइन वोल्टेज √3 टाइम्स फेज वोल्टेज होता है, सो यू कैन राइट इक्वल टू √3 टाइम्स V2 फेज स्टार। अब V1 फेज डेल्टा बाय V2 फेज स्टार मालूम है, उल्टा बोले सेकेंडरी टू प्राइमरी टर्न्स रेशियो दिया हुआ है 6, मीनिंग इज व्हाट V2 फेज स्टार बाय V1 phase delta is given as 6. So this is given as 6 here. You can write 1 by 6 √3. Now you can calculate V2L. V2L star would be equal to 6 √3 multiplied by V1L. V1 is given as 200. So it would be equal to what? 200 into 6 means 1800 multiplied by √3. So 1800 multiplied by √3 would be the answer. So the correct answer would be 2078 volt. Next सवाल देखेंगे। The iron loss in a 100 kV transformer is 1 kilowatt and full load copper loss are 2 watt. Maximum efficiency occurs at load. See, the loading at which maximum efficiency occurs is given by X is equal to square root of iron loss by full load copper loss. Just to put the values, iron loss दिया हुआ है 1 kilowatt, copper loss दिया हुआ है 2 kilowatt. There is a full load copper loss. So just put values here. So 1 by 2 means loading equals to, or the fraction of loading is equal to 1 by √2. And this is what the fraction of loading. Now see, load kVA at X of load is equal to what? X times the full load kVA. Full load kVA rating of transformer is 100 kVA. So simply you multiply full load kVA 100 by the fraction of loading at which maximum efficiency occurs. So X times full load kVA, that is equal to 1 by root 2 multiplied by 100 to give 70.7 kVA. Now you see next problem. Following graph shows the loss characteristics of a sheet of ferromagnetic material against varying frequency. Pi is the iron loss at frequency F. Hysteresis and eddy current losses of the sheet at 100 Hz are. देखिए, this is what the variation of iron loss per unit frequency with respect to frequency. You know, total iron loss expression Pi is equal to AF plus BF square, where A is your proportionality constant for hysteresis loss and B is the proportionality constant for eddy current loss. Now इसी को लिख सकते हैं आप Pi by F is equal to A plus BF and अगर Pi by F को y एक्सिस पर प्लॉट किया जाए and F को x एक्सिस पर प्लॉट किया जाए, then आप प्लॉट पाएंगे similar to your straight line plot on xy plane having intercept equals to a. ओके, सो यहाँ पर ग्राफ दिया हुआ है Pi by F वर्सेस फ्रीक्वेंसी का. देखिए इंटरसेप्ट आप कैलकुलेट कर लेंगे 0.01 इज द इंटरसेप्ट A एंड स्लोप दिया हुआ है 0.001. दिस व्हाट द वैल्यू ऑफ B. सो B का वैल्यू मालूम, A का वैल्यू मालूम, आपको देना आप डिटरमिन कर सकते हैं hysteresis loss and eddy current loss at 100 Hz. So hysteresis loss WH at 100 Hz is equal to A into 100. A is your 0.01 multiplied by 100 to be equal to 1 watt, and eddy current loss at 100 Hz is equal to B into F square. B value is your 0.001 and F square is your 100 square, meaning is what 100 into 100 to be your 10 watt. So eddy current loss is your 1 watt and hysteresis loss is your 10 watt. Next you see hysteresis losses are present in core of an iron core coil when the current in the coil is alternating. The current is unsymmetrical alternating only. The current in the coil is DC only. The current in the coil is sinusoidal only. See, whenever alternating nature of flux is impressed to core, yes, there would be the magnetization and demagnetization process associated to the core, and that causes the hysteresis loss in core. So the fundamental reason or the fundamental cause of the occurrence of the hysteresis loss here is the presence of the alternating nature of exciting current to the core. So the correct answer would be the current in the coil is alternating. Next is silicon content in iron lamination is kept within 5%. देखिए सिलिकॉन को ऐड किया जाता है हाई ग्रेड स्टील में just to decrease or just to reduce the hysteresis loss, और 2 to 5% ही मिक्स किया जाता है as because अगर इससे ज्यादा मिक्स किया जाएगा देना ब्रिटलनेस ऑफ कोर जो है वो इंक्रीज हो जाएगा. So see the options here. It makes the material brittle, reduces the Curie point, increases hysteresis loss, increase cost, is makes the material brittle. That would be the more correct answer here, and that is the preferable answer here. Next, if frequency of input voltage of transformer is increased, keeping the magnitude of voltage unchanged, then देखिए अगर वोल्टेज को चेंज नहीं किया जा रहा है और फ्रीक्वेंसी को इंक्रीज किया जा रहा है, मीनिंग इज व्हाट ड्यूरिंग ऑपरेशन ऑफ ट्रांसफार्मर वी बाई एफ रेशियो इज नॉट मेंटेन्ड कांस्टेंट. वी बाई एफ रेशियो को कांस्टेंट मेंटेन नहीं किया जा रहा है एंड वी बाई एफ रेशियो को कांस्टेंट मेंटेन नहीं किया जा रहा है और उसके साथ साथ वोल्टेज को कांस्टेंट मेंटेन किया जा रहा है. इस केस में if you analyze various conditions of hysteresis loss and eddy current loss based on the V by F ratio variations, then you can have the result that in this case eddy current loss is independent of frequency and hysteresis loss proportional to 1 by F to the power 0.6 for silicon steel. Okay, मीनिंग इज व्हाट, एडी करंट लॉस में कोई फर्क नहीं पड़ेगा अगर इस केस में और इस सिचुएशन में फ्रीक्वेंसी को इंक्रीज किया जाएगा मेंटेनिंग वोल्टेज कांस्टेंट, बट हिस्टैरिसीस लॉस में फर्क पड़ेगा। क्या फर्क पड़ेगा? फ्रीक्वेंसी इंक्रीज करने से हिस्टैरिसीस लॉस डिक्रीज होगा। सो सी प्लीज ऑप्शन से यार, hysteresis loss will decrease but eddy current loss will remain unchanged. So this would be correct answer here. Next, in the following transformer the secondary winding always kept closed. Say it is required in current transformer. Okay, low voltage winding are placed nearer to core in case of concentric winding because देखिए particularly in case of core type core based transformer LV winding is placed nearer to the core and by doing so you can reduce the amount of leakage flux, you can increase the amount of linkage flux and hence can increase the power transfer capability of transformer. Also it reduces the volume of insulation material required. That is a major advantage of using or of placing LV winding nearer to the core and HV winding farther from the core. So one of the option you see please, it reduces the insulation requirements. Okay, so see, if K is the phase to phase voltage ratio, then line to line voltage ratio in three phase star delta transformer is. So V1 phase star by V2 phase delta is given as K. Then it is asking to calculate line to line voltage ratio, that is V1 line star by V2 line delta. आप जानते हैं V1 line star is equal to root 3 times V1 phase star and V2 line delta equals to simply V2 phase delta. क्यों? क्योंकि डेल्टा करेक्शन में लाइन वोल्टेज और फेज वोल्टेज दोनों बराबर होता है. Okay, so just to put the values here, answer would be V1 phase star by V2 phase delta given. So root 3 multiplied by K, so K root 3 would be the correct answer here. Next सवाल देखिए, in an auto transformer of voltage ratio V1 by V2, here it should be given the relationship between V1 and V2 and let's see the correct relationship. That should be V1 is greater than V2. अगर V1 V2 से बड़ा होगा, देखिए दो पॉसिबिलिटी है. V1 अगर V2 से बड़ा है मींस ऑटो ट्रांसफार्मर का जो LV होगा वो आपका V2 होगा और HV जो होगा वो V1 होगा. मीनिंग इज व्हाट, K वैल्यू वुड बी इक्वल टू V2 बाय V1. अगर ऐसा है देन पावर ट्रांसफर्ड इंडक्टिवली पूछा जा रहा है. पावर ट्रांसफर्ड इंडक्टिवली इज प्रोपोर्शनल टू 1 माइनस K फैक्टर. सो K भी इंडक्टिव प्रोपोर्शनल टू 1 माइनस K. Meaning is what, be 1 minus V2 by V1. So be equal to V1 minus V2 by V1. So K भी इंडक्टिव would be proportional to V1 minus V2 by V1. So आप मॉडिफाई करेंगे सवाल में, यहाँ पर दिया हुआ होगा V1 is greater than V2 so that V2 is LV for ATR and V1 is HV for ATR. Next सवाल है, a stepped core is used in transformer in order to reduce. See, stepped core is used in transformer particularly to reduce the volume of the copper material requirement in comparison to that in case of your rectangular core or squared core. A delta star transformer has a phase to phase voltage transformation ratio of A:1. Phase to phase volt transformation ratio means secondary side voltage to primary side voltage. Delta phase to start phase नहीं, actually star phase होगा. So ये दिया हुआ है V1 और V phase delta by V phase star is equal to A:1. It is given. Then सवाल पूछा जा रहा है line voltage ratio of star delta is. So V line star by V line delta would be equal to what? So V line star equals to root 3 times V phase star and V line delta को phase के टर्म में लिख सकते हैं simply V phase delta. अब आप जानते हैं V phase delta by V phase star ये given है सवाल में A. So answer would be root 3 by A. So root 3 by A would be the correct answer here.